Welcome to Optimizing Public Works Projects, Why Civil 3D Outperforms AutoCAD, or as I like to call it, Civil 3D for the simple things. So I'm your host, Dave Young, work for a company called Repro Products. We're an Autodesk partner out of the Atlanta, Georgia area, but we do work nationwide and actually been around the world a few times with this stuff. So, all right, let's get started here. A couple things we said we're going to talk about in this is maps and imagery using real world coordinates, utilizing GIS data in your drawings, importing survey points, offset alignments and widenings, and contours from InfraWorks and point clouds. And finally, once we get those contours created, how to create profiles from it. A few things we did not mention is the ability to do best fit lines, arcs, and alignments. Curve tools. How can we get more information about an arc or a segment of a polyline other than just the radius and start and end points from it? Maybe take a look at the calculator that's built, curve calculator built into Civil 3D, and some other curve creation tools. We're going to take a little bit quick look at some COGO geometry functionality, how we can take a legal description and turn it into something on the drawing. And we're going to take a look at some drawing cleanup as well, and maybe a few other things along the way. So before we go too much further, a couple of definitions we want to take a look at. Number one, AutoCAD is a computer-aided drafting. AutoCAD, right? It's great for drafting, right? Kind of like the way we used to do, except now on computers, faster to change. On the other hand, Civil 3D is a design and documentation program. We create an alignment that looks very much like a polyline, but the stationing along that alignment is sort of a byproduct, right? We create a corridor. The section views are a byproduct of that corridor or of the alignment, in fact. Right? So there's a lot more to it. The things that we create have intelligence to them. If I create a storm drain, that pipe has a material, a slope, a wall thickness, a bunch of stuff that goes with it. So it's not just lines on the screen like AutoCAD is. Another big difference is AutoCAD has different entity types we can make use of. So AutoCAD has lines, polylines, and 3D polylines, but they have limitations. All three of them. A line has elevations at point A, the start and end. Polyline has a constant elevation, but it can have curves. A 3D polyline can have different elevations, but no curves. But a feature line, a Civil 3D object type, can have lines, it can have curves, it can have elevation points anywhere along that. So we see in here, we can actually come here and change elevations. We can change grade between points. Can't do that with a line. All right, polyline versus an alignment. If I draw a polyline, I could say that polyline is going to be the center of a road, and I could offset it 15 feet on each side, and I've drawn edges of pavement, right? But if I need to change it, I can grab a vertex on that polyline and move it around, but the offsets don't go with it. And if there's a curve there, the curve doesn't. One end of the curve will go with it. It doesn't maintain a tangency to it. If I use an alignment instead, it might look exactly the same as my polyline did, but if I change it, the offsets go with it. And I can actually add widenings automatically around those curves. So assume, a sharp curve around a mountain road switchback, right? I need my lanes to be a little bit wider on the inside so the trucks don't run off the edge of the road. That happens automatically with a Civil 3D alignment and offset alignments. Okay. Offset alignments can have widenings to them. I need to put in a passing lane or a turn lane. something like that. Yeah, I could draw something like we see up here at the bottom of the screen. I could draw that with AutoCAD polylines, but with a Civil 3D offset alignment, adding a widening to it, I simply say, hey, let's start that widening here, extend it for 400 feet. Oh, by the way, let's just transition back in over the next 100 feet. It will do that for me automatically. So let's take a look at some of these things in action. We're not going to do PowerPoint all day. So maps and imagery using real world coordinates. Let's take a look at that. So I've got a brand new drawing here, nothing in it. If I assign a coordinate system to my drawing, I can use the online maps. Actually, let's come over to this drawing. Okay. So this drawing already has a coordinate system assigned to it. I will say if you're using Civil 3D 2025, you can go to your settings tab, right click on the drawing, edit drawing settings, and change your coordinate system right here. That doesn't work prior to 2025. It used to, then it didn't. Right. So instead of using that method, there is a AutoCAD map command, ADE set coord sys. And you would set your coordinate system this way. It looks very similar, slightly different arrangement, but you still do type in a code or pick it from a list, right? Once your coordinate system is set, you will get a geolocation tab. If you go to the geolocation tab, right now, online map, I can see they're off. I can change that to say Bing aerial. And there we go. There's a Bing map behind my stuff. Now, it's not just this area. I can zoom out a lot. And that is the entire California NAT 83 Zone 6 coordinate system. Now, let me find my project again. If you don't like the aerial maps, you can always just bring up a road map, maybe for location, if nothing else. Starting in 2025, we can actually bring in some different Esri maps, like the Esri OpenStreetMaps, or maybe a light gray format. Just looks different. Okay? Different data source, that's all it is. Now this online map, if you try to print it, it's going to tell it online map will not be printed. Well, darn it, we kind of want that. You can always capture an area and just draw a box around what you want. If I turn my Bing Maps that to map off, that image is still there. Okay, that works. So let me take that out of there. That image is actually embedded in your drawing. It's not anything external to the drawing, it's part of it. Now you can do something similar in AutoCAD, but setting your coordinate system initially, you can't say, hey, I'm just working in Montana coordinate system. You've got to pick your point and rotation for those maps in AutoCAD. Civil 3D and AutoCAD map is just there. Now for the imagery, let's say you've got drone imagery, or you had your area flowing, you've got SID images or TIFF images of the entire county. You can bring those in as well. Okay. Now, we could do that in AutoCAD, right? You just type in XREF. You go find, attach an image and tell it which one you want to bring in. I can do that, but the next question is going to ask me is, where does it go? I've got no idea. That's not all that practical. Now, most likely your aerial imagery is geo-referenced. It could be a SID image that has the coordinate system in it. TIFF images could have the coordinate system embedded, or there's a world file that goes with it. Doesn't matter what it is. You can then use the map I insert command to bring in imagery. I want to bring in main site imperial, the same one I looked at it just a second ago. If I had a bunch of them, say I got 15 different images that cover the whole area, whole city or county, I could pick them all at the same time. I don't have to do them one at a time. Let's hit open. It's going to show me where is that going to go. If I'm picking a single image, I can change it. If I pick a bunch of them, it puts them in according to the geotag. I just do that and drop it in. It's right there. Comes in where it's supposed to. I do want to change the display order and send it to the back. Yeah, that looks about like it's supposed to. Pretty neat the way that works. All right. Utilizing GIS data in your drawings. How can we do that? Let's jump back to AutoCAD. I'm sorry, Civil 3D. This is an AutoCAD map functionality. Civil 3D is built on top of AutoCAD map, which is built on AutoCAD. So you've got the functionality of all three programs in there. So getting that GIS data in can be as simple as just drag and drop. So I'm going to find a data folder. I'm going to search for SHP. I'm going to grab my city limits, my parcels, and transportation center lines. I simply drag and drop. And there it is. There's all that data. Now I don't have it looking real pretty, but it's all there. If I zoom in a little bit on one of these, I can see, okay, there's a road. Now, when I pick it, it shows it kind of highlighted. It's just a dashed line, right? That is not anything I can really use. That is not a polyline. If I list it, it is a map bulk feature. It's for mapping purposes, for viewing only in this case. But I can go to its properties, and I can tell you that is Ponce de Leon Avenue. Right, so all that data that was in that shapefile comes into AutoCAD so I can see it at least. Same thing with a parcel. I can grab a parcel down here. Oop, that's the city limits. Try it again. Well, I got stuff on top of stuff, so it's kind of hard to find. But it's in there, but it's not really usable. Right? It's a good background imagery. I'm going to bring up my map task pane, which allows me to turn that data on and off. Or I can change colors or stylize it, whatever I want to do. I want just say limits in here. So being able to view it is great, but you can't take a road center line and offset it 15 feet to get edges of pavement, right? Or whatever it needs to be. Instead, if I want AutoCAD objects in my drawing, I need to use a map import command. I'm going to grab, let's say, transportation center lines and parcels again on my transit stops. Hit OK. Now I've already got a few things, a saved profile that I can bring in. In here, this would allow me to tell it what layers things need to go on, what data needs to come in with them, how to display them. I'm going to load a profile. It's that simple. And we see we now got a data column, and my drawing layers have changed a little bit. I'm going to bring in stuff in this little area right there. Hit OK. I was processing through a lot of data, and I brought in about 4,000 objects just that quickly. So if I go pick one of these, if I list it, it is a polyline. Standard old AutoCAD polyline at that point. If I bring up its properties, I can tell you that is Lenore Street. It's a local street because that's the data I told it to bring forward. I could then offset that or copy it or whatever it is I need to do with it. Same thing, I got a parcel down here. That is parcel ID, whatever that number is, Margaret D. Reitmeyer at 2707 Far Road. All that data from a shapefile or even Esri Online has been brought into my drawing as AutoCAD objects now. All right, what else do we want to take a look at? Importing survey data. How about that? If you're using regular old AutoCAD, getting survey data into your drawing is darn near impossible. Let me find out where I'm at. Somewhere over in this area. I'll just bring it in. We'll see what it looks like. So this drawing has not been set up correctly, but I just want to show you how easy it is to bring in. Right, I can insert points from file. This is going to bring them in as Civil 3D points with, a little bit of a, the point number, elevation, description. I'm going to grab a point file real quick. I'm going to set my format and go ahead and add. And somewhere in there, I should have, whoops, prospector, points. Let's just zoom dibs. I don't know exactly where it is. There it is. I get a bunch of points in my drawing. And my trees look like trees in this case. Now we could take that a step further. Instead of just getting points in here, looks like this. If you do a little bit of setup first, I'm going to bring in that same points file into this drawing. Let's go find that site survey again. Pick my format, hit OK. We've got a little bit more going on in here. I'm going to set my scale. Yep. Do a regen. I know somewhere in here, if I can find it, I'm supposed to have no, I'm supposed to have points in here that look like manholes and trees and fire hydrants and things like that. And I'm just not seeing any of them in here right now. Oh, there's a manhole. My manhole looks like a manhole symbol. So not the greatest example, but there's a power pole, looks like a power pole. I got a few of them in there. That is all just a little bit of setup in your Civil 3D, and you can make your points come in looking like you want to. You can use point groups to control which ones are visible, and they're in your drawing that quickly. If you want to go a step further, this is not quite the simple stuff, but I could do this, delete all those points out. I'm going to maybe use import survey data, make a new database real quick. Hit OK. Next, I'm going to go find that same point file. Everything looks good. Next, finish. Now I can bring those points in with line work. Now that's not the simple stuff, but it is possible to do that before you ever really, your drawing's halfway done before you ever get started. All right. Offset alignments and widenings. Okay. How can we do something like that? Oops, go back. Let's go back to Civil 3D, the right button this time. I'm going to bring up my geomap real quick so you can see what we're working with. And I've got an alignment right here for the center line of that road. Just so we know what it is, right? So this is a Civil 3D alignment we're looking at. I don't have any no labels on this, but you get an idea what it does anyway. That is more than just a simple AutoCAD polyline. Looks like a polyline, but it's not. Actually, that one is, sorry. I want to turn it into an alignment. So home, alignment from objects. I just use regular AutoCAD tools to draw it. I'm going to convert that into a alignment. Call that meandering way. We can go ahead and add major and minor labels on it if you need them. Hit OK. Now I don't see my labels on there, but that's quite all right. I want to show you offset alignments. Right, so I'm going to start over here, pick the alignment, go to offsets, and we're going to make one alignment on each side at 17 feet. Hit OK. That quickly, I've got a center line and 2 edges of pavement. Now, yes, I could have drawn that polyline and offset it twice, but can't move it too far. Notice as I move that around, the offsets are going with it. Oh, grab the right grip. I got to shorten my curves up. So notice as I move that around, everything just goes with it. I don't have to move into, start over basically is what we're coming down to. Undo a little bit. I think that's far enough. So the offsets are pretty handy. Let me do this. Let's take the right-hand side, and I'm going to add a widening to that. I'm going to start my widening about here, continue it up to here, or you can type in station values. This is based off the center line, 17. Let's go 34 feet. Twice, add a second lane, basically. Notice that widening starting to happen, goes around the curve nicely. We got our transition stuff over here. Perfect. We're done. Close it out. There's my widening on that. Try doing that with a polyline, right? And it is all tied. I can't move it too far. Let's grab that grip. It's all tied. Even that widening changed. I changed the center line alignment. The offsets and the widening all changed with it. All right. Let's come back over here. Oops, erase all. So I got something to work with. I want to take a look at creating contours from InfoWorks and point clouds. I'm going to do this pretty quickly. So actually, let's do a point cloud, LiDAR data. So I've got LiDAR data here showing his elevations. If I tip that up on a side, we see there's elevation changes in there. So that LiDAR data, whoops, that's fine. That LiDAR data can be turned into something pretty quickly. Start a new drawing. I want to insert or actually attach a point cloud. Let's go grab that Serpent Mound one. That's what I was just looking at. And quite probable your point cloud is going to be geo-referenced. So all you have to do is drop it in the drawing. So I want to create a surface out of that in Civil 3D. I just say, hey, there's my LiDAR data. I'm going to create a surface from that point cloud. I'm going to do a small area. Next, instead of everything, I'm going to grab a small area so it completes pretty quickly. Let's just grab right about there. I'm going to set these numbers to process fast. So create a surface, and we'll give it probably about 10, 15 seconds. And we should have a surface out of that in just a little bit. While that's doing that, hey, it's already done. Never mind. Now that point cloud is just a reference. I can detach it. I'm just going to delete it so we can see that surface. There's my contours from a point cloud. Pretty quick and easy to get them in there. And if I look at that in Object Viewer in Civil 3D, maybe change our style to shades of gray. Hey, there's that serpent mound part showing up in there. So it takes almost nothing to create a surface and therefore contours from LiDAR data. The other thing we may want to do, maybe you don't even have LiDAR data. Maybe you've got nothing. This is an area you've never worked in. I can use InfoWorks. InfoWorks says go to the model builder, define an area to use. It will build the model. It may take 20, 30 minutes to do it, you can go have a cup of coffee while it does it. So I got this one, and we look at that. That is not flat. There is elevation data to that. I can use that in Civil 3D. Actually, this drawing had it. All right. Still on that insert tab, I'm just going to open an InfoWorks model. Let's go browse and find it. It's small enough I can bring in the whole thing. Whoa, hold on. Make sure. That's why. GA83-WF. Match coordinate systems. Now we'll bring it in. It's a small model, so I'm going to bring in the entire area, but I do want to refine my selection set. I don't need everything. So I want to bring in just the surface. Right. So a few minutes ago, I had nothing. In here in a little bit, I'm going to uncheck everything, bring in just the existing ground, and let it do its thing. There is a surface and therefore contours created from an InfoWorks model, which takes all of 3 minutes to really build. Now, this data is coming from USGS. That's why it looks very pixelated. It's a grid-based system, but it's more than I had a few minutes ago. So pretty quick and easy to do both of those. Now, once we have that surface, we can actually create a profile from it. So back over here to create a profile, well, that's the serpent mound one, it'll work. I can just draw a regular old AutoCAD line. Right? I want to know what the profile looks there. I'm going to create a quick profile. Show that over here. There is my profile. Now my scale is pretty exaggerated, but that's what it looks like. How long did that take? Just a few clicks. If you want that to be a little more persistent, it might not be a bad idea to actually draw an alignment. So let's go home. Let's create alignments. And let's just make something coming up that hill like that, driving right over that serpent figure, something like that. Right. I'm going to pick my alignment. I'm going to create a surface profile from it and draw it. I do want to change this just a little bit. Won't be quite so exaggerated. Still pretty bad, but there's existing ground, right? And if I'm doing some new design profile on that, yeah, I could do that in AutoCAD too, but how long would it take you to create that view? So I want to create a design profile. This is pretty simple. I just go to Profile Creation Tools. We're going to say Draw Tangent with Curves. Now I'm not working for great design here, but I'm going to kind of draw where I want it to go, picking PI points. Automatically drops the curves in there for me. And we'll do that. Yeah, it needs some work. I've got a steep 33% grade coming up the side of a mountain. So maybe that's not the greatest, but you get the idea. You want to change it, just change it. Grab grips and move them. Want bigger curves? Make bigger curves. Even if you're not using this for anything but that, kind of handy to have those tools around. All right. Best fit lines, arcs, and alignments. Let's see what I can fake in here real quick. Let's come back over to here. Let's go just road for this. Let's say I want to make a little bit of a road going through here. I'm going to draw some regular old AutoCAD points. I should have had these already created, but yeah, these could be surveyed points and probably should be. So believe it or not, there are some points on the screen. Let me see if I can highlight those for you. I want to create a series of lines and arcs that go through that, but drawing something by hand might be a little difficult. Civil 3D gives us the best fit line, arcs, and parabola tools. So I can draw a best fit line from Kogo points, surveyed points to be great. I'm going to do from AutoCAD points. I'm just going to grab those points all right along in there. Notice the red line is where it thinks it needs to go, and it's kind of threading the needle down the middle of them. When I do this, it'll give me a nice little regression graph, and I could say, hey, this point right here, third one down, I'm going to leave it out. Watch that line shift just a little bit. We told it to exclude that point. Or maybe we'll exclude point number 2. Their line shifts. When you get it set up pretty good, go ahead and save it. There's an AutoCAD line, create a best fit. I could do that with my arcs as well. Or you got a whole road that's been surveyed, create a best fit alignment. We're going to do that from AutoCAD points. We're going to pick those points. Okay, we are not going to worry with any of our settings. Just see what happens. Get a little regression graph. Some of those are really far off, but yeah, my points were off, but it did it, right? It created a best fit alignment from all those points. And labeled how far they were off from that line. So I'm off, 8 feet on some of those. Ignore my poor point clicking skills. Curve data, curve tools. That was pretty quick and easy. Let's just come back over here. Let's just draw on the screen real quick a arc. In AutoCAD, if I list it, it's going to tell me a little bit of basic information of the radius, the start and end angle, but what's my curve delta angle? What's the angle? Yes, I can subtract those two numbers, but why? Right? Degree of curvature, things like that just aren't there. But Civil 3D gives us the ability to cut several different things. I can come over here to my curve tools and go to curve calculator. I'm going to pick that arc, and degree of curvature is 8.9446 degrees. Delta angle is 100.9 degrees. A lot more information. There's a mid-ordinate distance, tangent distance, all sorts of things in there that AutoCAD doesn't give me. There's also CG list. Pick that object. Now that one I do have to bring back up my text window, but I get a lot of information. The beginning endpoints, radial points, tangents, chords, deltas, same information, just different display. Another one that comes in kind of handy. I got some line segments here, right? I want to put a curve through that. I could use the AutoCAD fillet if I know the radius. Well, suppose I don't know the radius. I know, hey, that needs to pass through this point right there. Back under my tools, I've got a lot of different things. Create a curve on two lines, through a point. Let's do a curve through a point. Pick that line right there, and say, hey, it goes through that point right there. It did it. I didn't have to do any math or figure out offsets or anything like that to get an intersection point. I just make it go through that point. It's that simple. Kogo geometry. We got a little bit of that built into Civil 3D. It's kind of handy. Under my line command, I can create a regular AutoCAD line, or I can create a regular AutoCAD line by any of these other tools, by bearing or angle. So let's do one by bearing. So I'm going to pick a start point. I'm going to come up here. I want to go to the northeast. I want to go like maybe 70 degrees, 15 minutes, 23 seconds east. So I'm going to go to quadrant number 1. Bearing is 70 degrees, 15 minutes, 23 seconds. Let's go about 500 feet. And there it is. Now, if I want to do something else, I'm going to hit escape one time. I'm going to go to my transparent tools up here, and I've got a bunch of other things I can use, like a angle and distance. I want to turn, let's go 135 degrees. Let's go 300 feet with that. Or maybe I hit escape. I want to do a deflection and a distance. I want to turn off that by 17 degrees and go 350 feet. So you can use that to go around a legal description pretty easy. Now, some of that stuff is all here under the line drop-down stuff, but we've also got, as I showed you, the transparent, which basically just changes your input method to work with different things. You can draw by point number, point objects, bearing and distance. If you're working with profiles, you can go by a grade and a length. So, all right, drawing cleanup. Let's take a look at that one real quick. So drawing cleanup is useful if you've got an old drawing that's been around for 20 years, keeps getting added to, modified, and it's wrong. Okay, you got endpoints that don't snap together. You got objects that cross each other or just barely a small gap in between them. Duplicate objects, small objects, zero length objects, things like that. Just cleaning up your drawing. So there is a command called map clean, M-A-P clean. It allows me to clean up my drawing. So I'm going to just select everything in the drawing. And here's all the action. I can delete duplicates, erase short objects, break crossing objects, extend undershoots, right? Erase dangling objects. I got a line that just overshoots just a hair, right? Maybe someone didn't snap perpendicular to the line. They're 6 inches over, something like that. Zero length objects, weeding polylines, a whole lot of different things. You can add as many or as few of these as you want. Now the order you might want to think about, you might want to erase dangling objects, lines that overshoot. Erase those before breaking crossing objects, right? So I'm going to start adding a few. Let's erase short objects. Let's erase zero length objects. Delete duplicates. And then I want to say erase dangling. Let's go to break crossing. Oh, there's extend undershoots, then we'll break crossings. You can just add in what you want to. Now, each of these has their own tolerance. Okay, so if an object is less than 0.01 feet, I want to delete it. You can change those numbers, right? How close, what's our tolerance? How tight does it have to be considered a duplicate? We can change that number there as well. Normally I would do this as automatic. I'm just going to do it as interactive so you can see what it finds. So let's go ahead and finish that. And it's going to start showing me up here, okay? I've got no problems with that one. Erase short polyline objects. There's one of them right there. We can zoom in a little bit. There's some little segment there, right? Let's go ahead and fix those. Takes us to the erase short polyline segments. I don't see any of those. Actually, I do. 143 of those, right? It's going to get rid of those. Let's just go back and fix all of those. Delete duplicates. I got 6 duplicate objects in there somewhere. It's going to fix that, right? Erase danglings. Let's fix those. You extend undershoots. Apparently, I've got a few of those in there too. Don't know exactly if it's that end or the other, but something doesn't match up there. I'm just cleaning up the drawing, right? And crossing objects, got 56 of those. Let's fix all those. So nice little tool to clean up for drafting, basically is what it comes down to. All right. You know what? I think that is about it that I said I was going to show you. Yep, it is. Into my slideshow. So it wasn't quite a full hour, only about 40 minutes or so, but a lot of simple tools that you can use in Civil 3D that you don't have in AutoCAD. Right? Even if it's just using an alignment instead of a polyline for a center line of something. The fact that you can just move a grip and the curves go with it is way more powerful than regular AutoCAD. All right. Oh, that's it. Thank you for attending. Hope to see you all in the class sometime. Thank you very much for attending.